Are we alone in the universe? The James Webb Space Telescope might have the answer. For centuries, humanity has gazed at the night sky, wondering, are we really alone out here? The search for alien life has captivated our imagination, and now, thanks to NASA and its most powerful space observatory yet, we may be closer to an answer than ever before. In a groundbreaking announcement, the head of NASA revealed that the James Webb Space Telescope, JWST, has made a discovery that could change everything. Using its state-of-the-art technology, JWST may have found signs of life on Proxima B, a planet orbiting a star far beyond our solar system. This isn't just another space story. It's a potential turning point in how we understand our place in the cosmos. A telescope like no other, the James Webb Space Telescope is the most advanced observatory humanity has ever launched. Positioned in deep space, far from Earth's atmosphere, it gives scientists an unobstructed view of distant stars, galaxies, and exoplanets with astonishing clarity. Its giant primary mirror is over 6 times larger than Hubble's, allowing it to collect incredibly faint light signals from the most distant parts of the universe. This enables researchers not just to glimpse faraway worlds, but to study them in unprecedented detail, peering into the past and the future. JWST's powerful instruments cover a wide range of light wavelengths, especially in the infrared spectrum, which can penetrate cosmic dust clouds that block visible light. This gives astronomers a clear look into the birthplaces of stars and planets, regions that were once hidden. For example, NIRCam, near-infrared camera, helps us observe how stars form inside galaxies. NIRSpec, near-infrared spectrograph, breaks down light from distant objects into its components to reveal their temperature, composition, and movement. MIRI, mid-infrared instrument, lets scientists examine longer wavelengths of infrared light, enabling the study of colder objects like dust clouds, forming stars, and exoplanet atmospheres. Hunting for signs of life. One of JWST's most exciting missions is to search for life beyond Earth by studying the atmospheres of exoplanets, planets that orbit other stars. Here's how it works. When an exoplanet passes in front of its star, starlight filters through its atmosphere. JWST captures this light and analyzes it using spectroscopy, looking for chemical fingerprints left behind by gases like oxygen, methane, carbon dioxide, and water vapor. These molecules can hint at conditions that support life, or even life itself. What makes this telescope so powerful is that it combines tools like MIRI and NIRSpec to skim both mid- and near-infrared wavelengths, covering a full spectrum of data that can paint a detailed picture of a planet's environment. And even if a planet doesn't have the same kind of life or atmosphere as Earth, these methods still help determine if it could support some form of life. Comparative planetology, a new frontier. Another fascinating technique used by JWST is comparative spectroscopy. By comparing the light signatures of different exoplanets, scientists can identify similarities and differences, and potentially spot the chemical patterns that life tends to leave behind. This comparison helps scientists see how other planets stack up to Earth, understand what makes a planet habitable, identify candidates for further exploration, more than just aliens. While the search for extraterrestrial life is a major goal, JWST also plays a crucial role in understanding the big picture of the universe. It captures light that has traveled for billions of years, giving us a window into the early stages of galaxy formation, star birth, and planetary evolution. These insights help scientists piece together the timeline of the cosmos, understand how stars and galaxies change over time, track the life cycle of celestial objects, a game changer for space exploration. With every new observation, the James Webb Space Telescope pushes the boundaries of what we know. It doesn't just show us distant planets, it tells their stories. From decoding the makeup of alien atmospheres to unveiling the structure of ancient galaxies, JWST is reshaping our understanding of the universe. Its findings will guide the next generation of space missions, spark new questions, and perhaps, just perhaps, answer the oldest one of all. Are we alone? The road ahead. As JWST continues to explore the unknown, its data will open doors to new scientific discoveries. Whether it's identifying potentially habitable worlds, unlocking secrets of the early universe, or simply helping us see the cosmos with fresh eyes, this telescope is leading us into a bold new era of exploration. In short, the James Webb Space Telescope is not just an instrument, it's a revolution, a giant leap for astronomy, a potential key to discovering life beyond Earth, and a powerful reminder of how much more there is to learn about our vast and mysterious universe. One of the most fascinating things about the James Webb Space Telescope JWST is its ability to peer deep into the early universe. By analyzing life in the first galaxies formed after the Big Bang, scientists can explore the origins of the cosmos. This is a major breakthrough. It helps us understand how the universe has evolved over billions of years and how it continues to change today. The JWST is equipped with advanced instruments that allow it to look farther back in time than ever before. It captures faint light from galaxies that existed billions of years ago, giving us an unprecedented glimpse into the universe's beginnings. The discoveries made with this telescope are expected to reshape our understanding of space as scientists continue studying data from stars, galaxies, and exoplanets. These discoveries could challenge existing theories and lead to entirely new questions about our place in the cosmos. This telescope marks a huge leap forward in our journey to explore the universe and answer some of humanity's biggest questions, like whether we're alone out there. For centuries, we've looked up at the stars and wondered about life beyond Earth. Well, it may no longer be just a question of what if. According to NASA's top officials, the James Webb Space Telescope has detected something astonishing, possible signs of life on a distant planet called Proxima B. If this discovery holds up, it could change everything. Let's explore what JWST found and what it means for the future of space exploration. The James Webb Space Telescope is a cutting-edge marvel, equipped with tools that let scientists observe distant stars, galaxies, and planets like never before. And it truly lives up to the hype. One of its standout features is its massive 6.5-meter mirror, far larger than Hubble space telescopes, which has served us for over 30 years. This large mirror enables JWST to collect even the faintest light from the farthest reaches of space, revealing sights that were previously invisible. Before JWST, scientists could only theorize about what existed in the depths of space. Now, they can observe these objects with incredible detail. Alongside its giant mirror, JWST has a suite of sophisticated tools for detecting various types of light. For instance, its near-infrared camera, NIR cam, captures images using near-infrared light. This is key because infrared light can pass through thick clouds of cosmic dust that block visible light. With NIRCam's high-resolution capabilities, astronomers can study how stars are born within distant galaxies. Another tool, the near-infrared spectrograph, NIR-SPEC, breaks light from distant celestial bodies into its component wavelengths. This allows scientists to determine properties, such as temperature, composition, and motion, critical for understanding how stars and galaxies form and behave. One of JWST's primary missions is to study distant galaxies. By examining their light, researchers can figure out how old these galaxies are, what they're made of, and how they've evolved. Then there's the mid-infrared instrument, MIRI, which detects even longer wavelengths of infrared light. MIRI is essential for observing stars, planetary systems, and dust-rich regions where new stars are forming. MIRI also plays a crucial role in studying exoplanets, the planets orbiting other stars. It can analyze the faint infrared light from their atmospheres, identifying substances like water vapor or carbon dioxide, potential signs of life. These regions of star formation are often obscured by thick clouds of dust and gas, but MIRI can peer through them using infrared light, allowing scientists to witness stars and planets as they come into existence. When it comes to searching for life, JWST uses two major techniques: analyzing light and studying planetary atmospheres. Even if an exoplanet doesn't have visible signs of life like plants or oxygen, these methods can still reveal clues. One key tool is spectroscopy, which involves studying how light is absorbed or emitted by different elements. When a planet passes in front of its star, JWST can examine the starlight that filters through the planet's atmosphere. This tells scientists what the atmosphere is made of and whether it might support life. In short, the James Webb Space Telescope isn't just a scientific achievement. It's a gateway to understanding the universe in ways we never thought possible. And if its findings about Proxima B are confirmed, we could be standing at the edge of one of the most profound discoveries in human history. The James Webb Space Telescope, JWST, is revolutionizing our understanding of the universe, especially when it comes to exploring exoplanet atmospheres in the search for life. When a planet passes in front of its star, it leaves behind chemical traces in the starlight. Scientists analyze these traces using instruments on the telescope like MIRI and NIRSpec, which cover a wide spectrum of infrared light. These tools allow scientists to study the atmosphere in great detail. As the starlight passes through a planet's atmosphere, it carries information about the chemicals present. One of JWST's main missions is to identify biomarkers, substances associated with life, such as oxygen, methane, and water vapor. But finding these is just the beginning. Further investigation is needed to determine whether a planet is truly habitable or shows signs of life. JWST also uses a technique called comparative indicator spectroscopy, which helps scientists compare the light data from different planets. This lets researchers estimate the likelihood of life beyond Earth by studying and contrasting chemical signatures. What do you think about this exciting quest? Let us know in the comments, and if you enjoyed this video, give it a thumbs up and subscribe for more space discoveries. See you next time. Why JWST is a game changer. The ability of the James Webb Space Telescope to detect biomarkers in exoplanet atmospheres is a major step forward in the search for extraterrestrial life. It allows us to study distant planets in unprecedented detail and gives scientists critical clues about the conditions on these worlds. But JWST doesn't stop there. It can also look far back in time. By capturing light from galaxies that formed billions of years ago, the telescope helps us understand how the universe evolved. This includes learning about how stars, planets, and galaxies were born, how they interact, and how they die. Beyond the search for life, JWST is transforming our overall knowledge of the cosmos. Its powerful infrared capabilities allow it to see through cosmic dust clouds where stars and planets are forming, places invisible to regular telescopes. By analyzing the light from these areas, scientists gain insights into the life cycles of stars and the structure of galaxies. One of the most fascinating possibilities is JWST's ability to observe light from some of the earliest galaxies formed after the Big Bang. This helps us study the origins of the universe and how it has changed over billions of years. As data continues to roll in, our understanding of the universe is constantly evolving. Each new observation challenges old theories and opens doors to new discoveries. From galaxies to exoplanets, JWST is reshaping what we know and what we imagine about space. A new era in space exploration. With its advanced tools and infrared vision, the James Webb Space Telescope marks the start of a new chapter in space exploration. It's not just capturing incredible images. It's helping us search for signs of life, compare planets to Earth, and uncover the mysteries of the early universe. Whether it's finding oxygen on a faraway world or revealing the birth of stars hidden in dust clouds, JWST is leading the way. Its discoveries could fundamentally change how we see our place in the cosmos and shape the future of space travel. The journey has only just begun, and the possibilities are endless.